Hello, we're looking at problem number 2 in your geometry, part 2 textbook. This is found on page 523 of your textbook under lesson 8.5. It's talking about how to use the law of sines. In problem 1 on a previous video, we talked about the basic part of doing law of sines is comparing the sine of an angle to the opposite, the length of the side opposite that particular angle. And there's a definite correlation between that, which ends up being called the law of sines. So we're going to use the law of sines here. This time, instead of being able to find a missing side, we're going to use the law of sines to help us find a missing angle. If you look carefully here, you've got 120 here, and then the angle across, or the side across from it is 18. So that's why if we're going to set this up, we're going to say the sine of 120 is to 18. And you can see they've done that right here. It's going to equal, now, I don't know the sine of S, but I do know the side opposite it. So I'm going to write the sine of S is to 11, because that's what the law of sines does. Okay. Now, the rest is really just using your algebra and being able to solve. Again, I want to remind you, if you're using sine or cosine or any of those, you need to check your mode in your calculator and make sure that you're in degree mode so that you'll get the correct answer. So, if this is my problem, I'm going to cross multiply, which is going to give me 18 times the sine of S equals 11 times the sine of 120. If I then divide both sides, because I want the sine of S by itself, if I divide both sides by 18, then that's how they're getting this right here. It's going to be 11 times the sine of 120, and then divide all that by 18. Now, when you get that answer, if you do choose to get that answer, remember that that's going to give you some kind of weird decimal because we're finding the sine of S, not actually S itself. In order to find S itself, we've got to get rid of the sine, which means we've got to take inverse sine of this side, and you can see we've also done it right here, taking the inverse sine of the other. Now, they just left it all in parentheses. You'll be much more exact if you do. But you've got to take the inverse sine button, which is in most calculators the second. There's a second button, and then you press sine, and that'll give you the inverse sine. When you plug all that in, you're going to end up with something like 31.95396, blah, blah, blah. If you were to round that to the nearest tenth, it's going to make the 9 a 10, and it's going to make the 1 then go up to a 2. So it ended up just being 32.0. Okay, let's try the got it section here. Under the got it section, we have this triangle, and I'm just going to sketch one, and it doesn't have to be perfect. I'm going to call it KLM. It's telling me that L is 105, so I'm going to fill in 105 there. It's telling me that LM is 9. And it's also telling me that KM is 14. And it wants to know the measure of angle K. Well, again, that's the exact same setup as it should be. In this particular problem. So what we're going to do is we're going to say the sine of 105 is to its opposite side, which is 14, as the sine of K is to its opposite side, which is 9. Again, if I were to cross multiply, I'm going to end up with 14 sine of K equals 9 sine of 105. Then I would divide both sides by that 14. So the sine of K is equal to 9 sine of 105 divided by 14. So what they're saying is, in order to get rid of sine, you've got to always take the inverse sine, because they cancel. But what you do to one side, you must do to the other. So take the second sign, and then in parentheses, press in the 9 times sine of 105 and divide all that by 14. When you do, you're going to find that angle K ends up being like 38.4, rounded to the 10th place. Okay? And that becomes your answer for the measure of angle K. All right? So in example 1, we found out how to find a missing side using the law of sines. And in this example 2, we found out how to find an angle using the law of sines. Hope this was helpful.